Carbon and its compounds. Lecture number 2. In this lecture we shall be learning about hydrocarbons and some theory regarding it. Now let us learn about hydrocarbons. As the name suggests, these are compounds that must contain carbon and hydrogen. These hydrocarbons are classified into two types. Now let us discuss about the classification of hydrocarbons. Given below is a complete classification of hydrocarbons. Please have a look. Now we will be discussing about the highlighted part. Aliphatic hydrocarbons. These are carbon compounds which have a long open chain of carbon. These are classified as saturated hydrocarbons. These are hydrocarbons which have all carbon-carbon single bonds only. The other category is unsaturated hydrocarbons. These hydrocarbons have at least one carbon-carbon double or triple bond. Hydrocarbon with at least one carbon-carbon double bond only is called as an alkene, and their general formula is CnH2n. The hydrocarbon with at least one carbon-carbon triple bond is said to be an alkyne, and the general formula for an alkyne is CnH2n-2. Now let us learn about saturated hydrocarbons. These are hydrocarbons that have all carbon-carbon single bonds only. These hydrocarbons are called as alkane. Alkanes have a general formula of CnH2n+2. Given below is a list of alkanes. Please have a look. Unsaturated hydrocarbons. These are hydrocarbons that have at least one carbon-carbon double or a triple bond. Those with at least one double bond only are known as an alkene, and the alkene has a general formula of CnH2n. Given below is an example of alkene. Similarly, if in an hydrocarbon there is at least one carbon-carbon triple bond, then that hydrocarbon will be called as an alkyne. The general formula of an alkyne is CnH2n-2. Given below is an example of an alkyne. Coming back to the classification of hydrocarbons. Now we will be discussing about this part. Now let us study about cyclic hydrocarbons. As the name suggests, these are hydrocarbons which have a closed carbon chain. These are again classified into two types. Alicyclic hydrocarbons, which means that these hydrocarbons do not have a benzene ring in their structure. And the second category is aromatic hydrocarbons, which have a benzene ring in their structure. So if you have a aromatic or a benzene ring, and if a hydrogen is substituted by any atom or a functional group, then the entire compound will be known as an aromatic compound. Now let us learn about benzene. Benzene is actually an aromatic hydrocarbon which has a molecular formula of C6H6. It has alternating carbon-carbon single and double bonds. Given below is the structure of benzene. Now let us have a look at the other representations of benzene. There are in all six ways of representing a benzene molecule. You can choose any one of that. Coming to alicyclic hydrocarbons. These are those cyclic hydrocarbons which do not have a benzene ring in their structure. For example, C6H12, which can be written in either of the ways. The following loop shows that there's a closed chain of carbon. Now let us learn about aromatic hydrocarbons. As told ago, these are cyclic carbons which have a benzene ring in their structure. Again, now if you have a hydrogen atom of this benzene substituted by any other atom or a functional group, then the complete compound will be known as an aromatic compound. In the upcoming part of the lecture, we will be learning how to name the hydrocarbons. So coming to IUPAC nomenclature. IUPAC nomenclature is a convention to name the hydrocarbons. This convention was given by the IUPAC, which stands for International Union of Pure and Applied Chemistry. This convention says that any hydrocarbon name is of this format: a prefix followed by a root word followed by a suffix. Now let us learn about the root word. Actually, this root word represents the number of carbon atom in the longest carbon chain selected. Given below is the list of the root word for the corresponding number of carbon atoms. Please have a look, it's actually a bit simple. Now, coming to the suffix name. The suffix name actually represents the type of the hydrocarbon, like whether it's an alkane, an alkene, or an alkyne. For an alkane, the suffix name is ane. For an alkene, the suffix name is ene. And for an alkyne, the suffix name is yne. Now, let us learn the procedure to write the IUPAC nomenclature. First, we have to select the parent carbon chain, which is nothing but the longest carbon chain present. If at all there is a double or triple bond present in the carbon chain, it should be included in the parent chain. Number the parent chain starting from that carbon such that the double bond or the triple bond or the side chain gets the lowest number. Identify and name the side chain if any. For example, CH3 for methyl, C2H5 for ethyl, and so on. Also, identify the position of the side chain. Finally, we have to write the name of the hydrocarbon in the following format: position number, name of the side chain, then the root word, then the position number, and then the suffix. For example, 2-methyl but-1-ene. So, if at all we have a hydrocarbon which is an alkane, the position number of the suffix need not be written. It's not necessary. Now, let us learn about the types of formulae for writing the hydrocarbons. There are three ways of representing any formula. Those are molecular formula, structural formula, and condensed formula. For a clear understanding, here I take the example of pentane. Pentane can be divided, it means pen for 5 and ane for an alkane. So my formula is C5H12. Now let me show how to represent C5H12. In terms of a molecular formula actually represents the actual number of each type of atom present in the compound. So when I say molecular formula for pentene, it is C5H12 itself, where 5 and 12 represent the number of atoms of carbon and hydrogen respectively. Coming to the structural formula. Here I actually represent the perfect arrangement of the atoms. This is the structural formula. Now coming to the condensed formula, this is also called as a skeletal formula. It is a shortened form of a structural formula. Here what I actually do is, I just avoid representing the hydrogen atoms. So my structurally reduced condensed formula is the given one. The continuation can be found in the next lecture. Thank you.